All right, hello. It's probably not going to be the best explanation, so text me if you have any questions. I'll be happy to answer them. But it's going to be the calculus review for Physics C. To start off, uh, basically, if you want to get like the slope of a line, let's say you have a line 7x, the slope, you're just going to take the y value at a given point. So like if you zoom out a little bit, um, you would take like this point right here, or like here. Let me use 4x because that's going to be right there. You would take the point at uh, like when x is 1, y is going to be 4. Like right here. So 4 over 1, that has a slope of 4. But what happens when it's 4x squared? You could create a line that goes in between 2 points like this and find the slope. That's not going to be exact. So that's where derivatives come in. What this looks like is it's going to be d over dx or dy dx. Those are used pretty interchangeably, but basically d over dx is telling when you're going to take a derivative, and dy over dx is what a derivative equals. So no, what exactly is a derivative? A derivative is the point exactly, it's a point tangent to a line with the slope of a line at a certain point. So like at this point, if you look at like this curve, a point tangent to that would be you can't get a point tangent, but like, or I can't think of a tangent point right now, but like if you just had a line that ran like from here across and just touched at like this point right here, that would be a that would be equivalent to the slope of that line at a point for the derivative. That is a very bad explanation, but essentially to take a derivative, what you have to know is it's the slope of a line at a given point. So to take a derivative, this is your formula sheet, by the way. You can pick it up in the back of Levine's room. The derivative of x to the n, right? X is a variable, n is just a constant. So like it'll be like n to the fourth. X to the n equals nx to the n minus 1. So if you want to take a derivative, so the derivative of a function like x to the fifth is going to be it would be 5 because you multiply that in the front, x, and then you subtract 1. So it's 5x to the fourth. That is the derivative of that function. That's all you have to know for now. There's a lot more formulas. There's a couple more on here, but you don't have to worry about those. You will learn them in calc before you do physics. And it's just the slope of a line at any given point. And so why would that be useful for physics, though? Basically, if you look at the equations, you have like velocity, position, acceleration, all those. And velocity, position, and acceleration are all kind of connected because the derivative of position with respect to time is velocity. So it's dx, here we go, dx over dt equals velocity, and dv over dt equals acceleration. You can think of the d, that's just how it's written, like that. So that's the derivative of x with respect to time. So that's basically means you're deriving like an equation with the variable t in it. And you could kind of think of that as like a delta. So like distance over time is velocity, or velocity over time is acceleration. So another thing you can do though is if you take the derivative of a position function, it's velocity, and then if you take the derivative of a velocity function, it's acceleration. So then that would be what's called the second derivative, which would look like, it would be like d squared x over dt squared. So that's the second derivative. It basically just means you take the derivative twice. And so this is useful because if you're given like a position function, you're given x equals 8x 8x to the third, and it asks you what is the acceleration. So you take the derivative once, which makes it 24 x squared, and then you take it again, which makes it 48. Or this would be time. This would be time right because you take it with respect to time. And so you're given a position with respect to time. You take the derivative once, and then you take the derivative again. So then this right here is acceleration. And so that's useful, switching between position, velocity, and acceleration. So now what's an integral? An integral is the area under a curve. And typically you will see integrals written in this format from A to B. This basically just means if you look at this right here, A is the left-hand bound, right is the right-hand bound. It's just the area under. You can think of it adding a ton of tiny little like rectangles together, and that gives you your area. That is a useful concept to know because in physics sometimes it will give you like a graph, and you have to like look at. It'll give you like a line. It'll just be like a straight line up, and you have to like just do 1/2 base times height, the area of a triangle, to calculate the area under the curve. That's the idea behind an integral. And often, if you just have to like, if it just asks like for an integral, you can do this on your calculator. I believe it's like math 9, and then you can plug stuff in. But for now, you have to worry about when it doesn't have bounds. So this is like an indefinite integral. It's from any random point to any random point. It's this right here is the opposite of a derivative. It's kind of like how x squared and square root x are like inverses of each other. Derivatives and integrals are opposites. So if I were to take this, acceleration equals that, and take the integral of this, and then you would write it with a dt, letting you know that it's with respect to time. That's the variable that's doing it or whatever. It would have to be like that. And so this is then given on your formula sheet down here. This looks a little confusing. Integral of x to the n dx, that just means x is variable, n is constant, is 1 over n plus 1 times x times n plus 1 over here. Basically, if you want to take the integral of a function, let's just say any function, 8x to the 4th, then dx. To integrate this, you would first of all look at what's this. So this is a 4, so now you'd make it a 5. So let me just put it like that. So now it's x to the 5th, and now you would keep that 8 there. So now it's 8x to the 5th, and now it's over this top one right here. So it's 8x to the 5th over 5 now. It's very simple to do. They get really hard later on, but you don't have to worry about that now. And yeah. So then what that can be useful for is like how position, velocity, and acceleration are connected through derivatives. It's also integrals. Another thing with integrals is when you solve an integral, an indefinite integral, you typically add a plus c. It's just a plus a constant, because if you were to take the derivative of this, you would get 8x squared, or 8x to the 4th again, because they're inverses. But since a constant, if you take the derivative of a constant, it's 0. Derivative of a constant is 0. So then it would be plus 0. So you don't know what's there before. So it's just plus c. In this class, you don't really have to worry about it, but it is there. So like, that's how they get this kinematics equation. Because if you have acceleration and you take the integral of that, it is acceleration times time. And then if you take plus velocity, and then if you integrate it again, it is at squared over 2 plus vt plus x. And so you can transverse acceleration, velocity, and position through derivatives and integrals, because if you take the integral of acceleration equals velocity. And so if you're given a, like the acceleration equals a function that's just 8x squared, 8x squared, and it asks you what is the velocity. You would just take the integral of this, which would then be 8x cubed over 3. So it's pretty simple. So that's velocity. And then if you want to find the position given this, so what? Also, I just realized this is an x. This would be a t because it's time. It's always with respect to time when doing acceleration, velocity, and position. So then if you want to position this, you would then have to do this again, which would then be to the fourth. So then it's 8x to the fourth because you add 1. And then be over 4, so that's 12. You can simplify this, but acceleration, velocity, position. So that's pretty simple. Basically, what you have to get away from this is the derivative is the slope at any point on the line. So kind of how it works is like if you took 2 points and squeeze them as close together as possible, you would get like one tangent line across. That is the idea behind it. But it's the slope at any given point. Integrals are the area under the curve. They are defined by the equations you can find on the formula sheet. D over dx equals this, and the integral of x to the n equals that. You then can use those for acceleration, velocity, and position. The integral of acceleration equals velocity, and the integral of velocity equals position. The derivative of position equals velocity, and the derivative of velocity equals acceleration. So another thing is derivatives, integrals, they are inverses of each other. So if you take the derivative of a function and then you integrate it, it's the exact same, and same with the other way around. That's pretty much all you have to know for now. And derivatives, you will see them as like dy dx normally, or like dy dt, or like dx dt. Another way they can be written is like d prime, or like, so it'd be like d apostrophe. Like sometimes x apostrophe can be like the derivative of x, but you're probably not going to see that. You're going to see like the d over dx to derive it, or like the derivative of position with respect to time is what this says, equals velocity. How I like to think of this is like it's kind of like a delta. The d is kind of like a delta, so that means like position over velocity. Position over time equals velocity. That's all you have to know for now. You will have to learn a little bit later, but in general, your calc will catch up very quickly in comparison. This was not a great explanation, so let me know if you still have questions. Let me show you derivative. So like if you look on a line, this gray one would be the slope between the 2 points, whereas the red one is the derivative. Yeah. Another way you can see derivatives is also f prime of x. That means derivative, or if there's 2 of these little notches, that's f double prime of x, which means the second derivative, which means you take the derivative twice. That's pretty much all there is to know. Let me know if you have any other questions. Yeah.